Does anyone need a break? Or should it just continue? It's just something so totally per friend. No, it's fine. I think it's fine. Maybe some more tonight. So great to be here. Happy to really be here. We had yesterday code drafts, right? So it was an intensive day, and it was even an intensive night, I have to admit. So I hope I still can perform in the usual manner. I would like to talk about a topic which I didn't talk so far about in that sense. So there's no presentation, which is called patterns of legacy modernization by myself. And this topic sticks with me for quite a while now, right? So I do a lot in this transformation space. I find it very interesting, as we also said yesterday, that I find it much more interesting to work in legacy code than in greenfield projects. I always have the same problem, so for me it's very interesting to kind of, thanks a lot, to kind of get into, brownfield projects, try to shop them around, and try to kind of modernize them. And we will talk about this in a second. But first things first, for those people who do not know me, I'm David. I'm actually come from Vienna. I'm a coding architect at a company called Square. I co-founded the company 2 years ago. Before that, I worked a lot in Germany, consultant for various, especially banks and insurance companies. And at some point in time, I wanted to go back to Vienna. And like everybody, I guess, who founded his own companies so far, thought he could do it better than all the others. And that's why we started, let's build a company which we're happy to work for, and which basically operates in Vienna. The funny thing is now, as we grew, we decided to go back to Munich again. And that's actually where I'm going now. So that's why I'm not so often at community events in Vienna these days anymore, because I'm working most of the time in our Munich branch to bootstrap. But I'm super happy to always be here and to kind of, learn especially these communities that don't think in the science communities. And a lot of other communities in Vienna. But back to the topic, to the really interesting part. So patterns of legacy modernization, right? This is such a broad topic that I really have my struggles to bring this down into something that can be presented in, I don't know, 40 minutes or so. But in general, each kind of transformation, each kind of legacy modernization should usually establish the why. Right? And I think that that's already a problem in itself, that we need to understand what are we actually doing, why are we modernizing, right? And I think there are two big families of modernization. The one is, technical displacement. I'm definitely the wrong person to deeply talk about this. So we just have, an old system. Like, you have an info migration, you have an Oracle database. This Oracle database just, it's too much of your money. You need to migrate to the Postgres database. This is for migration. There are companies who are just focused on that part, right? Or, the same thing goes for code transformation, right? Was in a big project 3 years ago where we migrated the global mainstream mainframe system, copying system to Java system. And this was mainly really done automatically, right? It didn't really work back then. These days, it's a little bit better. I've heard with AI. So there's promising stuff that you at least really can translate at least, from one code to another. It will not make your code better, right? It will still be with what shitty COBOL code it will and shitty Java code. But this can solve the problem. And back then, it really solved the problem that the mainframe got so expensive. So we decided, hey, let's just shift it to Java. We don't care about the code, right? We really just care about the cost. And there's a lot of stuff. There's a lot of stuff where AI, and we'll talk about AI a little bit in a second, can help us. And we made really good experience the last couple of weeks or couple of months with reverse engineering stuff. Right? AI is not really good in refactoring. I will talk about this in a second. And building up a test frame. So AI is overhyped. No word on that. But especially working with legacy code, it can help us a lot understanding what's actually going on, and it can help us, kind of build the security frame that we can change the inner workings by having good test bed, good test frame. So what I'm usually talking about, or what I'm usually involved when we do legacy displacement or modernization, is business-driven displacement, right? And I will just call it time to market improvements, right? most of the legacy systems I need to migrate are driven by the single fact that, new features take too long. We are not kind of able to compete with competitors anymore because they build features much faster than we can in our legacy system, right? And this is, of course, for me personally, and don't get me wrong, but for me personally, much more interesting topic because this is, a whole social technical thing. You kind of need to understand the organization, you need to understand the code, you need to understand a lot of things to basically arrive in this short time to market. And that's what I would like actually to discuss today. Also, I also have to admit, of course, that these things usually come together, right? You're usually not migrating Java to Java. Well, sometimes we do these days, but of course there's an overlap. Talking about AI, as I just got on Monday in a workshop, and we actually got asked this question again, or we got into this question of how can AI actually improve us to solve all this stuff, right? Why do we actually need to do this on our own these days if we have ChatGPT and all the great stuff, or LLMs in general? And I will not dive deep into this. We can do this at the beer or today maybe the water afterwards. What's interesting is, all these AI tools which we have these days are heavily promoted and they're heavily good in generating new stuff. So, Copilot, LLMs, you tell them something, with this kind of 50 lines of code and it's just copy them over and you're done, right? Great stuff, really great stuff. The problem is that in most cases, when we as developers do stuff, we rarely write new code, right? That's 5% of our work. There's great research on this, but actually most of the time we do not write code, right? We try to understand code, right? We or somebody else will a few days or maybe hours ago, right? And we do a lot of other activities. So although there's a case for LLMs to kind of accelerate us writing new code, our main goal these days is not to write new code, right? And that's why it's interesting, because there was a great research from a guy from Coty. They've showed the product, right? They also do a lot of fantastic research from my perspective. And what they did is to basically figure out. So the title of the paper is called Refactoring versus Refactoring, right? You've probably noticed they factored something, things do not change. And if you do some change or some refactoring and it actually changes the behavior, then we call it usually refactoring, right? Because it's fucked up or it's it. And what's interesting in this paper is that they did this research, right? So they collected a lot of LLMs and asked them, hey, how good are you actually in refactoring stuff? And all of them are very good in, building or providing syntactically correct code. That's the problem, right? It combines. The problem is that most of them are actually not valid after them anymore, right? So they re-fuck up, right? So they refactor our code, but the code doesn't have the same behavior, which is of course highly problematic. And of course this tool will improve and this will improve, but at all current points in time, this is actually problematic, right? Also, they improve the healthiness. It doesn't bring us value if the code is afterwards correct. So if you go into this direction, you again need a strong test space to basically really ensure that we can do this with AI. And AI can help us building test spaces, but there's also again, of course, a wrong possible in that sense. So, but as I said, I don't want to focus too much on AI. And anyway, lots of people are talking about it, but I just wanted to, sort of certain sense at this stuff here. I think it's quite interesting. So when we do this, right, in general, we have two options. Always two options, right? This is basically also two options. In that case, we have two, right? We do it all once, right? Or we do it sequentially, right? And we all know this kind of big bang migrations, right? And they can work, of course. They have a very small problem. You just, want to have it solved at some point in time. And big bang migrations, small bang migrations are a good way to go. But in everything else, in any other situation where you start with complicated or even complex systems, big bang migrations just don't work, right? I at least from my experience, be happy to hear differently. And somebody who phrased this much better is Martin Kohler, right? If you do a big bang migration, the only thing you're certain of is a big bang, right? And I guess it's true, to be honest. And so we're stuck with step-by-step doing stuff, right? Incremental step-by-step migrations. And of course, that's a little bit more challenging, right? You just cannot say, okay, I take the old system and replace it with a new one at AX. I need to really figure out what I do and how I do it in which sequence. And for me, incremental step-by-step migration is a synonym for Slangy Fig, right? So I guess most of you know Slangy Fig better, not? Okay. Yes? No? You raise your hand? No? Okay, so not okay, 50%, that's good. So Slangy Fig, if you hear people talking about migration like me, they all say that's good Slangy Fig, right? So it's a synonym for migration. Everything is Slangy Fig. That's a problem, right? Also, the idea is very clever, and the very simplified version of Slangy Fig is based on this tree. I put this quote on my own in Australia, so I don't have the classical Slangy Fig picture. I have one which I took with my own handy camera, so I'm quite happy about it. And the idea is that this Slangy Fig, right? It's a plant in Australia, right? And it grows on existing trees, right? And it starts to build itself around this tree, and at some point in time, it kills the tree beyond it, right? Just the new Slangy Fig tree remains. And that's a nice metaphor for migration, right? And that's the whole idea of Slangy Fig, to say, okay, very simplified again. We have this huge monolith, right? And we basically put an API in front of it, a reverse proxy, and we kind of carve out the stuff which we want to carve out. And whenever we're going to witness against this reverse proxy, this API, we basically either forward it to the new port already, or we forward it to the old system. It's not carved out. Sounds very simple, right? The reality isn't. There's great post from Martin Fowler itself on it in the Slangy Fig application. So if you're not familiar with this concept, go to it. I think it's the only way to do it. But the problem is it's so fuzzy these days, right? As I said, everything is Slangy Fig. And of course, there's a lot of complexity in there. If you think about this picture, right? So the first is where to start actually. What should I take out of this stuff, right? And basically how to keep it in sync. Right? Do we even have to keep it in sync? In most cases, you probably have to, right? So if you start to move out things here, they kind of need to be in sync with the other stuff, right? And we'll talk about this in a second. And I would like to start with the where to start, because that's obviously a very interesting question. And again, Nick Kuhn, I think I mentioned him already. No, I didn't, right? But he was yesterday at the conference, and he has this kind of, I would say, decision matrix. It's a 2x2 matrix, and it basically just tells us, hey, take this in mind if you want to start an equation, right? And basically figure out, hey, what brings the most business value and what's the most riskiest to do. And I usually suggest our clients or partners to go somewhere here, right? To take something which is not the most complex stuff in your business, right? But something that proves the case, right? If you start here with low-hanging fruit, right? Yeah, okay, that's probably easy to migrate. If you start here, it takes you 2 years and you don't have a result, right? So you will not get the story through. To take something that I think Dave mentioned yesterday, right? That proves the scale, not just the proof of concept, but really proves that it could work on the whole system. So it needs to have some certain complexity. And usually we do this in 2 to 3 months to box 10 to figure basically out if we can achieve this or if ours something great. And if you have this monolithic system then still you need to decide, okay, you probably have a better understanding how complex this stuff should be, which you carve out, but basically you need to decide what to carve out. And there are actually, I would say, 2 options to go with, right? Either you focus on the data, right? So you say, okay, with entities here, the users transactions found the product, or you focus on the journeys, on the customer journeys, and the use cases on the workflow, however you call them, right? End-to-end processes that go to your system that bring value to the customers, to search for product, to order and pay a product, to track the order, right? And I'm a big advocate of focusing on the green boxes here, right? Because if you don't focus on the green boxes, you obviously end up in a system where you have then, entity service, right? We all know the entity service pattern, pattern like this. If you need to order a product, you first need to fetch the user, then you need to go to the categories, and from there you need to go to the user again, and then you probably need to go to the order history to in the end allow the user kind of to search for a product, right? Which is of course a mess because if one of these services is down, and it will go down, the whole system doesn't work anymore. This is what we tend to call a distributed monolith usually, right? Too many hops for really relevant customer journey. And I think also yesterday at the conference is that for me a good indicator for the quality of the distributed system is always how many hops do you need for the most critical customer journey through your system, right? If this goes too far away from one, you probably have your problem in modernization. That's why we tend to verticalize systems these days, right? Where we say, hey, we have service to search, the service to order, and the service to delivery. And that's actually what we should do here, right? So self-sufficient services that kind of, fulfills customer journey on its own. And the point is, I mean, I mentioned it already, but the search product just need to throw this service, and the service basically allows you to search a product, right? So you make your customer happy with just the same service, which of course increases the resilience of the system because you don't have to cancel your existing service to just fulfill on you. Right? And if we don't do it, and I often unfortunately see this being done, right, and we actually end up in this situation where somebody is saying, we need to cover stuff of our Java Enterprise monolith, right? So we take the user service, build a nice user service with a nice REST API, take to us, everything in place, a little bit of GraphQL, right? And then we figure out that basically the difference is not really too much value, because in the end, we have those customer churns, right? And those customer churns need to get resilient, need to get more autonomous in that sense. And if you just kind of carve out something, but the customer journey is usually not based on entities, but across entities, then you don't achieve high resilience, right? You don't achieve independent deployability, and ultimately you don't achieve faster time to market, right? Because you don't have autonomous team space in this stuff. So the way to go is obviously to shift our customer journeys, because then you have all those things, right? Which I mentioned before, that we miss when we go for entity platform. And a great way to do this, for example, to slice the customer journeys is the inverse convert maneuver. You know the inverse convert maneuver? Okay, 50%. So probably Converse law, right? Converse law tells us, hey, the architecture always looks like the organization. The communication path is in the organization to be really correct, but in the end, how you structure your organization, your software system will look like, right? I think that the plural example back in the days was always right. If you build a compiler, has 3 teams, it will be a 3-phase compiler. If you have 2 teams, it will be a 2-phase compiler. It doesn't matter if it's better to be 2 or 3-phase compiler, but in the end, I think this explains the story very well. And the inverse convert maneuver basically works this, right? You say, hey, you could of course now sit together here in the whiteboard, decide we carve out this customer journey, or we carve out this customer journey. This is how the target architecture looks like. Or we just say, hey, we restructure the organization, right? We structure the organization according to the target picture which we want to know. This is inverse convert maneuver. And again, I would love to talk about this more in detail, but therefore we just don't have the time. And by coincidence, a few days ago, we recorded a podcast with Nick Q exactly on this topic. So if you're interested in this, we talk about 15 minutes on our learnings, when we do this, when we don't do this, what's the complexity, what's the problems you can face if you do that. And if you now slice out those customer journeys, smart people, basically, some people in the room will already have figured out, hey, that's not that easy, right, David, what you're telling us there? Because of course, there is an overlap between customer journeys and data, right? So you spotted the problem. It's not kind of say, hey, we just slide out customer journeys, because there's this customer journey entity data mismatch problem, which also a couple of times already had on other slides, but I think it's always important to mention. On the one hand side, we have entities, right? On the other hand side, we have those customer journeys. These are usually our 2 dimensions we can basically slice both sides. And the problem is, if you have a product that probably needs entity data, and if you have product order, it also needs entity data. And if you have product delivery, it also needs entity data. And there's no overlap, right? So all of these customer journeys obviously need accounts, right? Made of example now, but you get the point. So this customer journey mismatch problem is unfortunately real. And the problem is, of course, that this would lead to the effect that we cannot build independent customer journeys. And in addition, it would also lead to the fact that we kind of have this dependency still, because probably what you would say is that, hey, this customer journey, let's say this is ordering a product to the user. And And then there is, this very nice monolithic database which tells you, come home, come to me, I have to use it for you. Just need to fetch it, right? And you say, no, not that easy, right? We don't do this. We build a proper API in front of it, right? So first of all, of course, you lose all the stuff if you do this again, right? All the stuff which we are gaining for by legacy modernization. Now we build an API in front of it, right? And we could, of course, add caching, but in the end, either API or directly SQL doesn't change problem dependencies there, right? In most cases, dependencies there, and the monolith goes down, the transformation did not work because the promise was that this stuff goes independently out of this, and this goes down, this is down, this is dependency compared to here, to the use case, right? And the first question, happening a little bit back and forth today, but the first question is, why is this actually a separate service, right? I often come into projects where people already started the modernization and they have built 5 new microservices, usually entity-based, and they figured out after the fix, okay, this is doing a lot of value, right? And then first of all, ask them, hey, why actually do you do this, right? Why do you do composing monolith? Why do you build microservices around your existing monolith? And what they usually say is better modernization, right? And that's the wrong answer, obviously. Again, I think I had this yesterday already on the slide. Modernization and distribution are 2 different things. You can have good and bad modernization, and you have highly and monolithic distributed systems. And we all know that bad modernization in monolithic systems is something which can be called a big ball of mud. But shifting from here to here probably not bringing too much value, right? Just giving you a distributed big ball of mud, right? I don't like the term distributed monolith, by the way, because it's kind of monolith is nothing bad, right? We should really call it distributed full big ball of mud, because that's what we're doing. We're distributing what we before didn't modularize well, and that's of course important. And better there to do your homework, right? To go with things like the well-structured monolith or all these fancy terms we have now for just proper designed monoliths, right? And then you probably have a reason to go for independent deployment units. And again, the 2 reasons are always the same, right? You want to have achieve high resilience, and you want to achieve independent deployability, because ultimately you want to achieve autonomous speed, and ultimately you will achieve faster time to market. And the problem is that if you start there, right, then often you're there, unfortunately. Way too often in our industry we're there, right? And we try to get over there, and if you do it like that, and the chances are quite low that you get there, right? The chances are quite high that you end up somewhere there, right? You didn't want to get there, but ultimately you are there, right? And it's bad. And then you try to push yourself from here to here, which is, well, I wouldn't say impossible, but I've never seen it work, to be honest. So what you need to do is you need to invest a lot of money then again, right? And this is where you see that microservices are getting composed together to a monolith, right? This is a good indicator that you're here, right? And you figured out, oh shit, I need to do first my stuff. I need to first get the modularization right. You go back here, and then you maybe start to carve for things that really make sense to be carved. Right? So if you're here, just don't go this route. Maybe just directly start like this, get your modernization right, and basically get from there to service things, right? And how much time do we still have left? No. How many? 10 minutes. Okay, that will be right. So let's make it quick then. So the point with incremental change is it's really hard, right? And it's really hard not because of the logic, right? You can easily carve out the logic. It's really hard because of the data, right? And in that case, I brought this example because it's a real world example or a real life example. I worked with a company, payment service provider, and they were really good in fraud checking. At some point in time, it just said, hey, we need to white label our fraud solution. And it just made a kind of a team out of it, right? Because it became an important part of the business. And that's a good example, right? Architecture is not per se bad, right? It's just not fitting maybe the current product vision or the current organization anymore, right? So don't blame anybody for having a monolith, right? At that point in time, it was probably the best solution, right? But obviously things have changed, and that's the same here, right? It was a good decision to say, hey, we have a single payment service, but it's been now figured out, hey, fraud detection is such a big topic. Let's carve it out. They needed to carve it out. And as you said, the hard one is data, the fraud data. So how do we get the fraud data over there? And yeah, as always, this big legacy systems, we had a lot of readers and writers on the existing system. So on the services on the database. And what we did, very often do is, right, to say, okay, we go for a big bang. As I mentioned before, we shift everything over, go down, migrate all the data, right? Go up again and hope that everything works, right? Because nothing worked. The new service didn't work as expected, right? So we needed to shift the whole stuff back again, right? Figure out, okay, we just shift the readers back, then we have inconsistency. So let's shift everything again back, have another downtime to shift everything back, fix the stuff, shift it over again, right? Start the whole thing again. And, it's just heartbreaking. I explained this story a couple of times already, and it just always gives me a heart attack. It feels real. And of course, you don't want to have this, right? And I think this is where we kind of need to become much better in legacy modernization. To kind of not come up with this, kind of dark stories where you already know that this will not work, and you will be the poor guy or poor woman sitting on a Friday or Saturday or Sunday to kind of do this migration, right? So a much better way, of course, would be here to really do it incrementally, step by step, right? Have all of these events, like data, CDC, for example, all very simplified, I know. Migrate readers first, right? If you have all the readers there, migrate the writers, or you can do it kind of in a way that you also play back the writes from the new system, and then you can migrate team by team and stuff like that, right? And if something goes wrong, you can just fix it, right? Can have a certainty that you fix it correctly this time, and then you redeploy it again without any downtime, without any hustle, right? Without anyone blaming you because you didn't reach it. And I think that's of course beautiful, and at some point in time you can shut it down. And this is not just a random story, right? Of course, that's very simplified. We all know that there is eventually consistency here and here, and a lot of things. But this is what you really need to do, I think, if you migrate legacy. And I can show you a real world example from the workshop I did I think it's 2 years ago already. But in reality, it's one of those examples where we exactly did this, and we do this actually all the time, right? You see here these 3 topics, which I showed before, right? And basically the legacy system was migrated by writing the database. We went this easily into the C to kind of, fulfill this database. Or another topic, right? Readers could already kind of decide a new data model or the new domain model, right? And basically we could apply it back to the old database, right? And at some point in time, you say, okay, let's introduce here some feature target. Where we say at some point in time, we don't write into the old legacy database anymore. We just write into the new system by REST API. We have here our new source of truth now, right? It writes back to our event topic, and basically it writes back to the legacy database so that we can still make reads against the legacy database, right? And at some point in time, we of course have migrated all the stuff, and we can get rid of the CDC topic. We still have here read model for the legacy purposes, analytics purposes, whatever you usually don't want to migrate, right? And we have shifted the data on the chip from here to here, right? Just to give you a real world example to make it feel a little bit more real how these things usually work. And besides zero downtime migration, or besides the fact that we did a zero downtime migration, if you just think about these concepts, right, you can do much more that gives you certainty that your migration works, that you can step back if it doesn't work. Like, for example, a canary release, right? Because most of you know canary releases. The idea is to basically say, hey, let's transfer 90% of the traffic to the old system and 10% of the traffic to the new system, right? You have then data dot or binary phrase in place, right? Then you figure out, hey, is this working properly? And if it's working properly, you can increase this. You can say, okay, let's shift 20% of the traffic over to the new, right? And if it's working on 50%, at some point in time, we shift all the traffic over to the new system. We can shut the system down, the old one. If it's not working, we can decrease it again. Say, okay, didn't work as expected, as usual. Let's figure out what's the problem. Let's fix it, and let's do it again. Right? This is the kind of mindset I think we need for legacy innovation. And for example, another interesting one, scientist pattern. We used this as an insurance company a few months ago again. The topic is quite old. It was introduced by GitHub a few years ago. I think when they changed the mechanism how previous merges work, right? So they built their own merge for whatever reason. They didn't use the classical merge to get out of the box to Git, but they built their own way to merge. I think it was more efficient, something like this, right? And they figured out it's not a good idea, right? We need to maintain our own merge. Let's just use the classical working Git, or the classical Git implementation, I would say. And what the idea is basically that you just keep both services running in parallel. So whenever a request comes in, you split the request into send this request to both services and figure out that those services return you the same result. And of course, this is just useful for certain use cases, but for GitHub, it was quite interesting, right? Because we got to create a comparison. First of all, how often those merges don't match, right? Where's the diff between the new solution and the old solution? That's why we use this insurance company, because that's quite interesting, right? Where's the difference in the growth? If you have an old solution and a new solution, you basically want to behave similar, right? And they also show how those two operations are performing on each other, right? If there's some edge cases where the new solution is maybe much slower than the new one and stuff like that. And they basically just practice over a couple of weeks. And after that, they figured out, okay, cool, people look better. Let's turn the old one down, right? Let's stop the signs and let's just go to the new solution, right? Just to give you some ideas what you could do there. Designs got very interesting. Of course, it's really useful if you have kind of calculation use case, right? Some business logic where you don't need to kind of solve the problem that you have the data maybe twice. If these operations are not pure in that sense, but have a lot of side effects. But if you have something which you need to migrate without a lot of side effects and science, definitely is really king. And saying king, I would in general say incremental migration is the king, right? Those things that I just showed you. And I think there's a proof for that as well. It's always in our industry, not a scientific proof, because we are not good in scientific proofs, but we kind of have opinions and we write them down and we say, hey, this proves the stuff. And I mean, one trustworthy person is here told Wolski, I guess. And I'm not sure if some of you know this ticket. You know it? If you're not, you should really read it. It's a game changer. I think it's again 20 years old. I think you should never do part one. Unfortunately, there was never part two. But in a nutshell, what Joe Wolski explains here is, rewrite is always bad. That's in a nutshell. And he explained it by a very good example from Netscape. But I didn't know it. I'm obviously too young for Netscape. But in 1996, and I'm just rephrasing what's written in the article, Netscape introduced version 4. Netscape has version 4. Version 4 was in the market. And the Netscape team said, hey, this version 4 is so technically depth that we completely need to rewrite this, right? The engine was scrapped, everything obviously was scrapped. I don't know it. I didn't ever see the code base, but they said we need to rewrite it, right? 4 years later, right, they introduced version 6, so there wasn't version 5. Probably rewrote it twice, right? Because rewrite was not good as expected. So 4 years later, they introduced version 6, so quite a time, right? Even back then, they probably didn't have some in that stuff. But that's the usage of Netscape, right? That's the user usage. And it wasn't a peak in 1996, right? And it died around 2000, right? And obviously that's exactly the time when those people said, hey, let's completely rewrite this stuff, right? Because of course, if you completely rewrite a thing for 4 years, right, then your competitors are not waiting for you and saying, okay, rewrite. We also will not introduce new features, right? We have our business sportsmen. This is not happening, right? And that's obviously one of the reasons why Netscape died. And that's bad, right? Because if they would have succeeded, we would have probably never seen Internet Explorer, which would have all our lives a lot easier, right? But yeah, that's for me one reason, or that's an example I also bring at university when I teach there to explain people, hey, do your refactoring, tidy up your stuff, do it constantly, right? I think also you always say, right? Don't do it at the end, don't plan in 2 weeks of previous factoring after each year, right? Do it constantly and make it, and then it works. But obviously, unfortunately, sometimes in situations where it's not possible anymore, and it was not your fault, right? The monolith grew over time, and it's just, you cannot migrate this stuff anymore, right? And yeah, where we often see this is at big enterprises, and as I said before, I often work with banks, and you can learn a lot of banks how to do their stuff, right? Because banks, they are good with money, obviously. And what I learned from banks is this good bad bank strategy, which you can also apply for legacy migration. And what a bank often has in mind, right? It says, hey, it's always 80%, 80-20 again, but 80% of the customers just use 20% of our products, right? These are the good customers, right? They just take whatever we have, the simple stuff, right? And 20% of the customers, take all these complex products which were invented 15 years ago, which nobody kind of wants to sell anymore, right? And that's exactly how they also operate very often. And I worked in a bank a couple of years ago where, this high 2026 revolution hit the market and every bank said, we need new web banking. And, the problem with web banking in banks is it was so bloated with features, right? It would take you 2 decades to kind of build all these special features for special products they introduced 15 years ago and didn't sell for the last 10 years anymore. And they actually had this problem, right? So complete replacement of the web banking solution wasn't really possible. Most of these web banking solutions were really completely outdated from the technology perspective. So this good bad bank approach made a lot of sense to say, hey, what are actually the 80% of the features, the 20% of the features that 80% of our customers need, right? And then it built fancy new web applications that basically were sufficient for 80% of the users. And if you basically one of these other 20%, which is all the new fans, all this complex features, then it just got redirected to the old web thing. And that's still there. This project I just mentioned. If you buy or if you have some special products, they still didn't migrate it because they just say, hey, we don't see a case. These products will die over time and they will die out, right? So why should we migrate them? And I think that's, for example, a very interesting and thoughtful idea to do so, right? And for example, Windows, I'm not a Windows user, obviously, but I'm a software engineer. So, everybody who has a problem with his printer or his laptop calls me. So do my parents, and they have Windows. And I figured out just a few weeks ago, right, that they basically did the same thing. So if you want to change something in Windows now these days, they have this fancy UI that configure your stuff. But if you really need to do the crazy stuff, right, you get back to the Windows 80, 98 system configuration. Basically, they followed this good and bad bank strategy. And one last one before I sum up, when it really comes to, and this is more on the strategic level, of course, right? This is not on the event-based stuff that I showed you before. But another great book is Dual Transformation. I'm not sure if you know this. It's more from how to keep businesses up and running. But Dual Transformation actually brings interesting ideas in that sense that they say you need to challenge your own company from time to time. And so you have your sustainable business, it's working, and you basically have new joiners on the market which are challenging consent. So why are you not doing this your own, right? And I think, for example, George, in that sense, in Austria was a good example for this to say, hey, let's build something sidetrack and let's figure out if it's working or if it's not working. And we did a very similar thing at the pharma company 2 to 3 years ago, where actually we were in the same situation. We had this huge legacy system, and there were people in the company saying, hey, it's much cheaper to just build something from scratch in the sidetrack, right? And there were people in the company saying, hey, let's just improve it, right? Let's continuously improve it. And the problem is you cannot really prove it, right? You cannot prove what's the right decision, right? Well, Jos Paul tells us let's better do the continuous improvement. But at some point in time, maybe the system is really that broken that you just break your fingers on doing so. And what they really did, which is of course kind of cost intensive, is that they followed this transformation A and transformation B to say we have those people, and your goal is to kind of improve the system, right? And we take a bunch of other people and tell them, hey, build a system from scratch, right? And after 9 months, we sit together, or after 1 year, and figure out what is actually the better system now, right? And of course, you need to figure out first how to measure what is the better system. That time to market, incidents, stuff like this. It's usually a good indicator. And then you can basically decide at some point in time, okay, we stay with the old solution or we go with the new, right? And there, actually, if you look at it, there's a couple of use cases out there which did this. And one use case, one company which is very publicly talking about it, so if you want to research further on this, is crazy. I'm not sure if you still know Brazy, they did this presentation software a while ago, and they had the problem that they built up on an old Apple solution or Apple technology, which was just not supported at some point for browsers anymore. So it was clear that they will kind of, get lost. And they again had the same situation. Do we completely rewrite the stuff from scratch, or do we try to migrate it from Apple script to JavaScript? And they did this. They said, okay, let's split up. Let's do some people work on a complete rewrite, and let's do some people work on the old solution. I'm not sure what's the result. I think the old solution won, but don't prove it. Just look it up. And another example is, for example, Google Inbox, right? They did the same thing, right? They did Gmail and they did Google Inbox, and wanted to kind of challenge Gmail, right? And in the end, they figured out, okay, Gmail is one feature. Let's just take the best stuff of Google Inbox, let's add it to Gmail, and let's kill Inbox. Right? So these are good examples how you think a little bit outside of the box if you think of migration and the time and the sparing partners to do so. But I guess everybody's looking forward for some hope here now. So let's quickly sum up what I told you. And yeah, first of all, I hope it was good enough because, as I said, it's the first time I talk about this, the first time I try to categorize my thoughts around this. So we'll for sure need a few additional iterations on this presentation. But I think what's really important, and maybe I didn't stress this way enough yet, is to understand and communicate the why, right? That's important, right? Why are we actually migrating? And there are various reasons to migrate, and you will not kind of, solve all of them with migration. And get C-level buy-in for this, right? You don't have C-level buy-in for migration, which takes usually 6 to 1.5 years. And I'm not saying that you have the first result after 1.5 years. I will talk about this in a second. But you need to obviously C-level buy-in for that, right? Derive the target picture that would solve the why and decide how you measure your success. Again, very important. Really define where do you actually want to go and why do you think that this will solve the current problem, right? Double loop this, think again about it, figure out, hey, does this solve the problem? But don't invest too much time on this target picture, right? It's not really useful besides the fact that you give people a vision, right? Don't invest 3 months in figuring out how your beautiful architecture should look like in 2 years, right? Just waste time. Just start doing it then, right? Focus on the transition, focus really on small steps and kind of, make sure that the steps bring value on its own, right? And if you did this, of course, communicate it transparently again to your sponsors, to everyone in the organization to show, hey, this is making value, right? This is bringing us kind of additional stuff. And I already raised it before, but I think this is there, right? And it's not that people did a bad job a few years ago. If you need to modernize your architecture, it's just that things change, right? And make tune over all stages in a way that you kind of consistently make good architectural decisions. But in the end, if your product shift, if your organization is growing or shrinking, you need to re-architect, right? Or as Neil Ford even says, it's more drastically, everything constantly changes in unpredictable ways, right? It's the main constraint of software. And that's why I think it's so interesting to work in brownfield projects and to kind of help people getting this stuff right. Thanks a lot. I hope this was useful. Sure.
The slide with the event box. Could you talk about the technologies that you used in your experience to implement, essentially to carve out the customer journey and to keep in sync the two parts of the system in the transition?
Well, I mean, then the pizza would be cold if we go into detail about this now.
Just an overview.
Sure, I get your point. Here it's even written right, we use Citizen, change data capture. So it's basically in that case, it was Postgres database. So we really kind of went against the change log of the database. And based on this, we produce events. Those events are crap in that sense that they are not really business events, right? We tell you, okay, we updated something, we inserted something, we deleted something, right? You don't want to have others communicating over these events, right? We consumed this in the new vehicle cloud in that sense in our new service, right? Put it in a database. It is an outbox pattern, and then we basically provided the real critical events, right? So the domain events. And the problem with these migrations is often that you cannot say, hey, we stop here, right? No more additional readers, no more additional writers, right? New writers and readers will come all the day. And that's why you can, if you do it like this, if you can stop here, right, and say, hey, that's the first thing we do. So you see a simple transformation and writing a useful topic, then you can already get at least new readers getting rid of the old system, right? Because with the migrations, I think we often have the problem that we tell, hey, please don't use this old system anymore. And then people say, okay, what's the use instead? Well, we don't have something yet which you can use instead, right? And that's one of the things here, for example, right? And then we just reapplied them again, and we needed to, of course, ensure that we don't have duplicates, right? Because otherwise you will run an endless loop. But you can do this simply by saying, hey, is this vehicle the sample state in that case already booked? And if not, then you do it, right? And that's the foundation. Now we have the circle where we can do all the crazy, all the nice stuff, right? We have everything which we actually need, and now we can start to migrate, and we say, hey, we people over here, and we say, hey, old legacy systems don't lie to the legacy database anymore, but lie to when a REST API, right? And by doing this, we shifted the source tools, right? Before this was the read model, now this gets degraded to the read model, right? You always want to ensure that you have one primary player who's kind of in charge for your data. And that gets, of course, very individual, right? You can do this completely at once, or you can do this by segment, by data, right? Okay, use this data, and then, so first of all, this gets, I don't know, owner of users, but we still stay owner of the section, stuff like this. So you need to communicate this and think about it, right? But in general, CDC is very useful. If we don't go on Oracle, because that's very useless, right? Unfortunately, but that's Oracle's fault, not CDC or not the business fault. I think in general, event-driven architectures help a lot because it's
and there was like queuing system or topic system like Kafka or something similar as implementation or just out of curiosity.
In that sense, it didn't really change too much, but it was Kafka. That's why it's called topic here, right? We used Kafka to connect this CPC.
Okay, thank you.
Thank you. So basically what I think what many of us are doing is creating architectures which fits the way how we wanted to develop systems 10, 15 years ago. And even now, I would argue that maybe in 5 years, 10 years from now, it would probably look quite different. It could look quite different, especially with the advent of AI and how it would look like. What kind of code are you actually still creating yourself? How much are you still refactoring? Instead of creating new, especially in connection with the DDT approach. What's your thought on this? Basically, because what you're arguing for is, and I have done this myself as well. You create a journey which takes minimum 10 years, depending on the size of the company. Even if you invest all the company's money, it will take a lot of time, and there will be a lot of challenges, right? And so in the beginning, things will get worse overall architecturally. Certain user stories will get better because once you have migrated them out, that's fine, right? But overall, it just adds complexity, and it costs a lot of money. But in the end, maybe in 5 years, it will look quite different. Right?
Yeah, very good point. That's really great. So I think you need to be careful with your promise, right? In rare cases, it really makes sense to completely decompose the monolith. Just give us this example, right? Because again, a lot of stuff is good to live there. It doesn't need to scale, doesn't need to be touched. Just let it die there, right? So I think if somebody comes in and tells you, hey, we migrate away the whole monolith in 1 year, then it's usually not a good idea because there's no business value anymore, right? So take out the customer journeys that really make a difference, right? Either they are too unstable, either they are too hard to maintain or too hard to add new features, right? But that's on that point. So there's of course then two architectural worlds, right? You still have something in a monolith, and you have something in a more distributed way, maybe, but that's not per se bad from my perspective, right? And the second question was a little bit how does it all evolve? And so I think it goes down. When do you do this, right? When do you start to say, okay, it's too bad now, we need to do something? And again, that's a very individual decision, right? If you are a developer and say, hey, this feels way too hard to do this, right? And it's usually a good indicator that something's wrong with the architecture. But it's not automatically a sign that you need to start off such a migration project, right? Maybe you're good to go for the next 9 months with the old stuff. And the next 9 months are, important for you as a company to survive against competitors or not, right? But again, then we're at the technical depth, right? We'll grow, and some point in time you will have to do it. But I cannot give you an answer when you should do it and how you should do it. But I think you really need to kind of keep this in mind. And for the AI stuff, I think that this will accelerate legacy migrations. There's a lot of study currently how the kind of added code on GitHub increased since GPT was introduced. So obviously people building new code is crazy these days. I mean, we do not really know if it's causalization or correlation, but you see that when LLMs were introduced, there's way more new added code on GitHub than it was obviously before. So I think, as I said before, LLMs are very good in generating new stuff, but they are still very bad in migrating old stuff, right? There will for sure be a time window where we have a problem based on that fact. Yes. Okay, so they want to harmonize them all.
The other one is the code basically preempt and all of the things like supposed to
Yeah.
The dual thread.
Yes.
But the experience lesson there basically everyone is going to have to rest.
Yes.
Yes.
Yeah.
2 or 3 apps, but yeah,
yes.
You look at when you leapfrogging, you have to assume you're not going to lose your testing.
Yes.
Doing the test after each year.
Yes. Yeah. Yeah. I would agree. I think it's yeah, at least a way to prove that it did not work, right? Rewriting it.
Banking, the new banking, the new, the multi-client banking.
Exactly. Yeah. Yeah. So we at this bank which I explained, and I had this I think in previous presentations, where we built this new web banking. This bank was very clever in terms of first trying to figure out what do our customers actually do, right? Which is not often the case when we build new solutions. But they figured actually out that, I think 93% of the screen time of people using their mobile banking app is basically detecting what is my current balance and what are my latest transactions, right? And if you think about it, that costs you 10% of your time, right? 80% of your time you figure out how you log a credit card, right? Which nobody ever does on the app because anyway just call somebody to get stolen the wallet, right? And I think that's a very good point there. And that's why I like this good bad bank approach, right? To say, hey, what is really needed, and for the rest, just send them back to the old system.
Basically, all it is, it's connected to all the other banks. They were
Yeah. Cool. Thanks.
Thank you.
Thank you.